Hey guys, this is my third time recording this, but we'll get it. Okay, my program isn't working that well today for recording my stuff. Hopefully it works this time. So today we're doing 8.4, testing the difference between proportions. This is the T-chart that tells you what we're doing, and the only thing you need to add is A16 right here for critical values, so you might want to add that in. Okay, we're going to go down to here. The idea behind today is that I'm going to do example 1 with you, and then you're going to do example 2 yourself and see if you know how to do it. So, testing the differences between proportions today. So I'm going to read example 1. Let's see, it says a study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants in pickup trucks show that 86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seatbelts. So the first thing I decided to do was to write out my stats down here. So for passenger cars, it was 150. That was their sample size. And 86% is their p-hat. Pickup trucks was 200 sample size and 74% for a p-hat. And then, as you can see in this formula up here, we're going to need X1 and X2 eventually, so you need to kind of have those numbers on hand. So to figure out, remember X is just the number of successes. So if you take quickly in your calculator 150 times 86%, you get 129, which is how many people must have said yes. And if you take 200 times 0.74, you get 148, which is how many people would have said yes for pickup trucks. So, okay, let's look at the steps here. We have to verify the samples are random and independent. We know they are, because it says in the problem. The second thing we have to do is figure out P bar, and these names are getting ridiculous, P bar. So for that, we have to take x1 plus x2 over n1 plus n2. So let's see, x1 plus x2 over n1 plus n2. Okay. And if you add those up, you get 277 out of 350, which is 0.79. So that's what P bar is. And then Q bar is 0.21, because that's just this is like the average success, and this is the average failure, and they add up to 100%. Okay. Next we need an H sub O and an H sub A. So their claim is that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks. So they're saying basically that the proportion of the passenger cars or pickup trucks is equal to the proportion of passenger cars. So this is the claim. The alternative is P1 is not equal to P2. Now I'm going to draw a quick bell curve. I'm sure you're sick of drawing bell curves at this point, but hopefully you're getting better at it. I'm not. Man, look at that one. It's been years that I've been doing this, and I'm not getting any better at it. Okay, whatever. So it's two-tailed. Nice and perfectly even there. And let's see, the alpha is 0.1 right there. So we need 5% in each tail. And if you look up 0.05 in the middle of the chart on A16, you get negative 1.645. And then you make it positive over here, 1.645. So those are our rejection regions. Now we're going to do this horrible formula right here, which is p hat 1 minus p hat 2 minus p1 minus p2. Remember, we're assuming that that's 0, so that part's just 0. And then all that nonsense on the bottom. So let's try it down here. So first thing we need is p hat 1 minus p hat 2, which is 0.74 minus 0.86. over the square root of, let's see, in the bottom we need, oh, that would be minus 0 there, just in case you're keeping track on the top. And on the bottom, it should be p bar, which is 0.79 times q bar, 0.21 times 1 over n1, which is 200, and 1 over n2, which is 150. Okay, if you put that into your calculator successfully, you should get a z-score of 2.73, which is over here in that rejection region. So I'm going to reject. Remember, the first thing you think about is the null. I'm going to reject the null. And then I'm going to, because the null is the claim this time right there, I'm going to reject the claim. I ran out of room, so I'm not going to write out the sentence, but the claim was that the seatbelt wearers are the same in passenger cars and pickup trucks, and clearly that's not the case. So interesting. Apparently people in pickup trucks are not fans of wearing safety belts as much as if you're just in a car. Okay. So now's the time to pause the video and to try example 2 by yourself. I'll be doing example 2 in just a moment. And I'm going to show you how to do it on your calculator so that you can use those programs. All right, pause that video. Pause, pause, pause. Do it. Do it. Okay, a medical research team conducted a study to test the effect of cholesterol-reducing medication. At the end of the study, the researchers found that out of those people, 301 died of heart disease, and of another one, for a placebo, 357 died of heart disease. Pretty grim study. All right. So let's start comparing the two. We've got, oh, I actually realized this should have been a negative 2.73 on the first one, which would have hit over here instead, but the results are still the same. My bad, though. So, that because 74% minus 86% is negative. And if I had switched the two, which I did on my original notes, I would have had 86% minus 74%, which would have been positive. But either way it works because it really doesn't matter which one you call N1 and which one you call N2. No idea why I decided to switch it up from my notes, that my practice test that I did the first time, but whatever. So, on this one, we're going to write out some information first. Alright, so we got meds and the placebo. So for the meds, I think this time they talk about X first. I'm going to call the placebo N2 and the meds N1. And by the way, it does matter on this one which one you call which. I guess it really doesn't matter which one you call which, but then you might have to switch what your null and alternative hypothesis are, because we are saying in this one that the death rate is lower for the people who took meds. And so the other one, it doesn't matter as much because it's a two-tailed, so it could go either way, but on this one, it does matter which side you're on for positive and negative, so be careful about that. Okay, N1 for the meds was 4,700, and 301 died. And then in the second study, 4,300 people took the placebo, and out of them, 357 died of heart disease. This must have been a very long study. So on this one, see, we have the x's. We don't have the p-hats, so to figure out the p-hats, you have to take 300 divided by 4,700, which is 0.064, and over here,